All right, guys. So I'm going to pull up our Canvas page and our problem here for our fire up. All right, so there we go. So you're told that you have a checkerboard and it has an area of 64 square inches. Now, there's a claim that the side length of this checkerboard is 32 inches because the square root of 64 equals 32. Okay? So you need to tell me on your thumb, true or false. Show me true is a thumbs up, false is a thumbs down. Is the square root of 64 equal to 32? That's basically what the question is here. Okay? Is the square root of 64 equal to 32? That's what we're thinking here. Okay, that's what we're checking. All right, well, here's the way we can check this, okay? Remember our area formula from the other day? A equals x squared, okay? An area is 64, right? How do I solve this for x? How do I undo squaring? I take a square, what class? Square, yep, square root. Very good. Okay, so I take square roots of both sides. These cancel out on the right. So I'm left with x on the right, and the square root of 64 is 8. Ladies and gentlemen, that is not 32. Okay? So Marita's claim is false. Okay? Ever see how that works? Great. So why did we study these square roots a little bit more and go a different direction with them on Monday? I'm sure you're all wondering that because I kind of left that as a cliffhanger, right? You couldn't sleep for a couple of days because you were trying to figure out what I was going to do with this, right? Yeah. Uh-huh. All right. So here's what we're going to do. All right? It's going to tie into what we're about to talk about today. Okay? Today, what we're going to do is we're going to focus on right triangles. Okay? Now, have you guys ever talking about right triangles in the past? You know what a right triangle is? A right triangle contains one right angle. Correct. Okay? One of the interior angles is a right angle. Okay? Good. All right. So I'm going to get you started here with just a little experimentation task because I love to see you guys work on those things. Okay? So I have one right down here for us. Let me erase this first so it's ready for my next class. Okay. Now, there's my triangle. Okay. What I want you guys to tell me is, okay, my right angle is down here in the corner. Oops, hold on. I just erased it. Now, if you see that little square box that's in that corner of that right triangle, okay, right here, that little square box I just wrote in there, that indicates that angle is a right angle. Okay, that's your right angle. Okay, and those two sides of the right triangle are perpendicular to be in a right angle. Are we good with that? What I want to know from you guys is, I want you guys to try to figure out, okay, just by talking with the group mates for a minute, okay, what the length of the side that's marked with the question mark is. Okay? That's what I want you guys to try to figure out. How long is that side? All right? Give about a minute or so, then we get some group answers. Go. Okay? Start talking. I want to hear some good stuff. Okay? Discuss. Okay? Make sure you can mathematically prove your claim. Okay?
Or more. That times height, so length times width, so 415 times height, so that'd be 4, but that just gives us the area. It doesn't give us the side.
All right, 30 seconds to finalize your answers, guys. Okay, make sure everybody's in agreement. I'm going to put you guys here and report out to me.
Half or something? You have like a half or something in there? I don't remember. So we're going to 12.
Okay, 5, 4, 3, 2, 1, 0. Let's start with my yellow group. What do you guys think the length is? I'm going to write these up here on the screen just so we have reference.
So we said either 6 or 12.
6 or 12. Okay.
We said 12, but we said 12 because 4 times 3 is 12. But then we remembered something, get the area of a triangle. It's something of half.
Okay.
So that 12, 6 is half of 12.
Okay. All right. Okay. Very good. All right. So, green group. You said 12 because of 4 times 3. Okay. Blue group. You said 6 because you think it's 1/2 of 4 times 3. Okay. Now, we know that the area of any triangle is 1/2 times the length of its base times its height, right? So does that also mean then that, because I think that's what some of the math was that you guys are trying to go with on this, correct? Okay. Does that also mean then that the length of this side right here that I'm about to highlight, so right here, okay, is also found by the same formula?
I don't care.
What do you think?
You could probably figure it out if you reverse the formula somehow. Like, instead of multiplying and dividing.
Okay.
Would you?
Maybe. All right. Maybe. Or, okay, what we're going to have to kind of get towards here is an idea that you might not have realized exists to find the length of the side of the triangle yet. Okay? Now, what we would tend to do in a regular year is we would spend a day and go through how we get this relationship to actually work out. But for your purposes today, I'm going to really cut through the chase. I'm just going to kind of get to the point where we just use that relationship. Okay? So in order for us to do that, we got to go through some vocab so you know how we identify some of these sides up here on this triangle. And we also need to go through what the tool is that we are going to use to do this work. All right? Those are our 2 objectives today. All right? So I'm going to cut away from here for right now. And I'll go ahead and reset this for a minute. Okay? So hold on to those thoughts, okay, about whether or not the side length is 6 or 12. You might be right. Okay, I'm not saying that. I'm not disproving anybody at this point. Okay, but I think we all have a little bit of an eyebrow raised that usually we don't use an area formula to find a side length. Is that fair to say?
Yeah.
Okay. All right. So let's go ahead and get to our notes then, and I'm going to get my notes set up here, and then we're going to talk about what this setup is here, okay? And the tool we're going to use is called the Pythagorean theorem. Have you heard the Pythagorean theorem before?
Oh, yeah, you told us about this.
I did?
You just said.
Oh, okay, like at the beginning of the year?
No, Friday.
Oh, on Friday. Oh, well, thank you for paying attention. Okay. There's a lot here on this slide, so you need to grab a picture, a screen cap of it. This is a very important slide. Okay, a very important screen. So everybody get a good picture of it. There's a lot here marked. I'm going to help you out. Okay. Are you guys ready? All right, so let's first of all talk about some of the terms that we use to identify some of these sides of these triangles, okay? These terms only apply to right triangles. Now, the 2 sides that make the right angle, okay, the 2 sides that form that box that are in the bottom left corner of your triangle, those 2 sides are called legs. That's why they're highlighted red and blue. Okay, that's why I highlighted legs red and blue as a combo. All right, so you can match everything up with the term, okay? Now, the long side of a right triangle has a really funny name. I don't know why it's called this, but you know what? You saw this word before, I believe, when we did the functions video, when we did the metamorphosis video, and all the critters went through the nuggetizer, whatever it was called. Remember that video? And one of the words that popped up during that time we were talking about different math words was hypotenuse. Ever seen that word before? Perhaps, maybe not. It was just a quick flash. Okay, but the hypotenuse is the longest side of a right triangle. Okay. Now here's the really cool thing. There's a very cool thing from geometry that says that the longest side of a triangle is always opposite the largest angle. Okay? So, you can always determine what side of your right triangle is the hypotenuse, because in a right triangle, the largest angle is the right angle. Okay? All right? So, whenever you are looking to figure out which side is the hypotenuse, you're looking to see which side is opposite the right angle. Notice how this side here, C, okay, is the hypotenuse because it is farthest away from that right angle there. Everybody see how that works? Okay? So when we say opposite in geometry, you'll learn this a lot more when you take geometry in high school. Okay? When we say the word opposite, we mean farthest away from. Okay, or directly across from. Okay, good things to know. All right, so way back when, okay, civilization was getting kind of used to things. Okay, a Greek mathematician named Pythagoras discovered for any right triangle that if you square both values of each leg and add them together, okay, so if you take a squared and you add it to b squared, that sum equals c squared, the length of the hypotenuse squared. And he proved this to be true. Okay? He proved it to be true. And what we would tend to do in a regular year is that you would actually do the proof yourself. You get to see how this actually works. What he did was he took, I'll just kind of summarize it here for a minute. He took each side of the triangle and made a square out of it. Okay? And then figured out that the area of each square made by the legs, okay, was all the area made by the square from the hypotenuse. And that's how he's able to prove the Pythagorean theorem. Okay? So, you might have heard somebody along in your life say a squared plus b squared equals c squared. That's the Pythagorean theorem. That's what this applies to. Okay? And on your next assessment, you get the theorem. Okay? You don't have to memorize the theorem. All right? I give it to you. It's going to be right there smack dab on your assessment. Okay? The question is, can you use the theorem to find what you're looking to find? Okay? And that's what we need to be working on for the next couple of days. So everybody okay with how the Pythagorean theorem is and how we might use it and how it gets derived? Okay? So just remember, okay, that the two legs, when you square their values and add them together, equals the square of the hypotenuse, the length of the longest leg. All right? So we're going to try an example now. All right? So let's scroll around here. Okay, we talked about that question, right? How do we always quickly identify the hypotenuse of a right triangle? I gave that to you this time. All right, so we're going to find the missing side of this triangle. Okay? Get a picture of it. Or draw one of your own, whatever works best for you. Better draw quick. Okay, so here's what we need to do. When we do a problem like this, the first thing we need to do is identify what information will be given about the triangle. Okay, so you need to know if each leg that you're given was either the hypotenuse or a leg. Okay, because that will help us determine what the missing side is and how to find it. All right, so let's do thumbs up, thumbs down. Look at the side that's 8 meters. Okay. On your thumb, thumbs up if you think that side is a leg. Thumbs down if you think that side is a hypotenuse. Okay? Is it a leg or a hypotenuse? Remember how to find the hypotenuse? We just talked about it. Okay? It is a leg. Very good. It makes the right angle. Okay. How about the 15 meters? Is that a leg or the hypotenuse? It is also a leg. Very good. Okay. So in this particular case, class, we need to find what side, a leg or hypotenuse? The hypotenuse. Okay. Now, you might have noticed that what letter do we assign to the hypotenuse for our Pythagorean theorem? Look at it again. Hypotenuse will always be assigned letter C. Okay? We can plug it in the theorem. So, now, since A and B are both legs, it doesn't necessarily matter which one is A, which one is 15. You just got to pick a combination and go with it. And you can have the different combination than your neighbor. And that's fine. Okay? It'll still work out the same way. But C always has to be the hypotenuse. That's the catch. All right? The C is always the hypotenuse here. So, let's get some letters assigned to these. All right? So, Lily, 8 meters. You want to make that side A or side B? A. Okay. So make this one side A. Well, that's 15. Be side B. That means that the question mark is side C. Okay. Everybody good with that? All right. Let's write it down. Okay. Now I'm going to colorize it this one time, but then after that, I'm not going to colorize it anymore. All right. So I'll do A squared plus B squared equals C squared. All right. And whenever you start a problem like this for me, for this topic, you have to start by writing down the Pythagorean theorem. That's your first step. Okay? Because this has now become an algebra problem. I'll explain why. That's why it's a good topic to start with, because it kind of bridges our algebra topic with our geometry topic. Okay? It's a good bridge in between there. No, but we just did algebra in the last unit. Okay? It was all algebra stuff. Scatter plots, functions, equations. Okay? Now we're starting to go into our geometry unit. So this is a good transition topic. Okay? Because it involves a little bit of both. Okay? All right. So now the next step. Replace A and B with the given numbers. Okay? So what is the value of A? 8. So this becomes 8 squared. Okay? And then what is the value of B, class? 15 squared. And we are trying to find C squared, correct? Okay. All right, so far so good. Now, it's time to start doing the math, okay? What is 8 squared? 64. And 15 squared. Very good, Baron. 225. And you may use calculators on this topic too, okay? You can. This equals C squared. Now, I need to start solving this for C squared, all right? Solving this little equation we've made. I need to start solving for C squared. You can raise your hand and tell me what they need to do next in order to get this going for solving for C squared, okay? Madeline? You do. You add 225 and 64 together. What's that sum? Monica, thanks for raising your hand. 289. Thank you, guys. Okay, 289. All right. And now, so here's where we are. Okay? Are we okay with this so far?
So you don't have to square 289?
No, because you already squared the numbers before you added them together.
Okay.
All right, good question. So here's the thing. I know what C squared equals. Now, if this length right here on my triangle was C squared instead of C right here, if that was C squared, I'd be in business. I'd be done. That's not what's happening here, though. This is not C squared up there on my triangle. That is side C. Okay? So the question becomes, how do I get from C squared to C? Okay? Lily? What do I divide by? Do I divide it in half? Or do I make it a square root? This is where
We'll do that
Monday's lesson
too.
now comes into play. What do we have to do on Monday to get from x squared to x? We had to do square roots. Yeah, okay. So that we already did that problem side by side where we had the x squared equals 30 on both of them, and one person did it by 2. We said that was wrong because 15 squared didn't become what we needed to become. Yeah, that's the downfall every single time. Okay. When you see when you see a square term in your equation, you got to take square roots to get rid of it. Okay. So we're going to do that right now. We're going to take square roots here and here. Those cancel out. I'm left with the c on the right side. And when you take the square root of 289, you'll get the final answer on the left side. Raise your hand when you get it. Okay. Charlie. 17. That's nice that 289 is a perfect square. That's not how that worked out, right? No. And we have to talk about that. Okay. 17 what? This has a unit attached to it? 17 meters. So, ladies and gentlemen, you just solved your first problem using the Pythagorean theorem. Okay, so C has to be 17 meters. Okay, that's how we get it to work out. Ever see how that works? Think everybody's gonna be okay with this? Good. All right. Very good. Very good. All right. So here's what we're going to do now. I'm going to give you problem B to work on. Okay. I want you to try it yourself. Try it yourself. I'm going to walk around. If you want me to check your setup of your equation, I'll be glad to do so. Okay. So if you want me to check this step right here, where you plug in the numbers, this one right here, okay, for problem B, then I'll be glad to do that. Okay, before you start working it out. Okay. Otherwise, I want you to try the next one. Here it is. What's the length of the question mark? Okay? And don't worry about the final answer. We'll talk about that together in just a second, all right? Are we doing okay? Question for me? Setup looks good. Nice job. Okay, keep going. Looks good to me, Charlie. Good job. Okay. You've got another minute or so to look at. Then I want you guys to check with your group mates to see if you guys all are okay with how you did it. Okay.
And we will be able to use calculators on the test.
Calculators are allowed in the next assessment. Yeah, I think calculators are allowed for the rest of your assessments this year.
Oh. So that means only if they're big numbers or stuff we need to add calculators for at least.
There might be one or two where it might not be an essential tool that you might not need to use, but it'll be there for your disposal.
Will we need it for like humongous numbers? Will we have humongous
I don't
numbers?
know if we're going to have it. Well, we might have some in the next topic, some larger numbers. Yeah, we might have some larger numbers. volume so necessary. Yeah, you probably did, but we're going to do a different change.
Okay. I think the only thing we'll get it was like 2 days. Everything was 3D.
Volumes for a three-dimensional shape. Yeah, looks good. It could be. We're going to finish it together, okay? We'll talk about what we need to do when this happens, okay? All right, good. Mel, you good? Tyler, okay? Okay. Good. We're going to talk about that sort of question and then treatment alone, okay?
That's literally all it is.
Oh, so you just
You just do this.
That's 6 squared is not 30.
Well, yeah. Just,
Well, that's what the theorem says to do. We're using a theorem. We're using a theory. The rule says you have to square the sides to get the liquid diamond.
So I just put 7.81 like that.
Come from here, you just square it, make that right triangle. It's a little complicated, okay? All right, back with me. 5, 4, 3, 2, 1, 0. Okay, who wants to talk me through this? I want somebody who can talk me through it from start to finish. Maren? Great, okay. So what's your side A up here? Okay. What's side B? I'm just going to say in blue this time, guys, okay? So A squared plus B squared. Whoops, that's a really awful looking B. B squared equals C squared, okay? You're up.
So I did 5 squared, 6 squared.
Good. What is 5 squared?
25.
And 6 squared?
36.
Okay. Now, I need to see all this work. Yes, I need to see all this work on the assessment for these problems, okay? It is an algebra problem, basically, okay? The geometry is that you get to use Pythagorean theorem. That's where the geometry comes into it. But then it becomes an algebra problem. So you have to solve it like an algebra problem, okay? And that might require showing some algebra steps on some additional problems yet this period. We'll have to see how it goes, okay? All right, what's 25 plus 36?
61.
Okay, so 61 equals C squared. Then what do you do, Maren?
Then I went ahead and did 61, and then I put like the box around it.
The square root symbol?
Yeah, I'm sorry.
You gotta take square roots of each side. That's an algebra step. They'll put C on the left, or right, I'm sorry. Now, everybody, class, is 61 a perfect square number? No, it's not, okay? So, here's the deal. You have to follow what the directions say, okay? Because you're going to probably approximate this number. If it didn't say to approximate, the answer is square root 61. You leave it alone, okay? If it said round to the nearest whatever, then round to the nearest whatever. For our purposes, for this lesson, we're going to round to the nearest 10th, okay? 1 decimal place. So you're going to put that in your calculator and get an approximation, okay? What's the approximation, Maren? 7.8. All those in favor? Good? Good. 7.8 what? What's the unit? There we go. Perfect. You just did your second one. Are we okay with that? All right. Now, I might not be doing C. Let me take a look at it here. No, we are going to do C, actually. Okay, so pull up C here.
So sometimes it'll go down, sometimes
You just have to follow the directions. Okay, yeah. Just follow directions on your problems. It'll tell you either to leave your answers. If it doesn't say to approximate, then leave it with the square root. Okay, if it doesn't go to an integer. Okay. If it's square root of like 64, then yeah, take that to 8. Okay. But if not, if it's not a square root of a perfect square, then you have to leave it as a square root. Good question. Okay, so let's talk about this one together. Okay. You ever got it down? All right, you guys ready? Now, this might look a little different to you. Okay? All right, so here's what we're going to do. All right, somebody raise your hand and identify one of the sides as A, B, or C. Okay? Take a risk here. Good here? 25 is A. So you think 25 is a leg of the right triangle? Or is it the hypotenuse of the right triangle? Or how to determine whether it is or not? Which one is it? It's the hypotenuse. What letter do we use for the hypotenuse? That's correct. You guys see that C is the 25 is the hypotenuse? Check its placement in regards to the right angle. Okay? There's your opposite relationship right there. Everybody see that? So this time I'm giving you the length of the hypotenuse as one of your two sides. That's going to make it more interesting, ladies and gentlemen. Okay? All right. So this is C. Okay? Okay?
Always the longest line.
It is. But sometimes that can be deceiving, so you have to look for the placement of the right angle. All right? It's always opposite the right angle. So if you can't tell based on length alone, look for the right angle. Okay? It's the side opposite the right angle. All right. So, Tyler, do you want to call 7A or B? It doesn't matter at this point. A. Okay? So then we're going to have to find side B, correct? Good. Set it up. It's the same theorem in the same position. Yep. Okay, you're not going to change the starting place. Okay, you're going to start with the Pythagorean theorem. All right. Then you're going to let the numbers dictate what you do next. All right. So plug in. Do we know A? Class, do we know what the value of A is? 7. A is 7. Okay. So I'm going to write it down here. 7 squared. Do we know what B is? No, we do not. Do we know what C is? Yes, we do. Okay. Good. All right. 7 squared is 49. We do not know what B squared is. Okay. What is 25 squared? 625. I know that one by heart. I've been around a little bit longer. Okay, now this is interesting because B squared is not by itself. Okay? Check this out. If I draw my line through my equal sign, B squared is not by itself. Okay? So, how do I get B squared by itself? Take a 30-second discussion in your groups and tell me think about what you have to do. Then I'm going to pick somebody at random to tell me. Go. Okay, back with me. Tris, did you guys talk about what you need to do? What do you need to do? Subtract what? Yes, you do. Nice job. You have to solve this for B squared. Okay, so it's time to do some algebra. Okay, you're going to subtract 49 from each side. You get B squared equals 576. Good. Okay, and now you can take square roots because B squared is by itself. You couldn't do it before because B squared wasn't by itself. Okay, so you have to subtract 49 so then you can do your square root step. So then you take square roots; those cancel out. And you get B equals the square root of 576. And I believe that's a per square. It is 24. So it's 24 inches. Okay? So now you see an example both ways. One where you have to find the hypotenuse, one where you have to find a leg. Okay? It's not necessarily harder, it's just different manipulation of the terms. Okay? So instead of adding the two legs together, you have to subtract one from the hypotenuse. Okay? Yeah. All right. So I want you to get down D for me. Okay? Get down D, but then we have to quit today because we're about ready to transition. Okay? All right. And this will give you guys a chance to get one down. So then what I would like for you guys to try to do is maybe work on this one tomorrow. Okay? You can start your assignment tomorrow, but we're not going to make it due tomorrow though. Okay? We have a couple things to work on Friday. Okay? And then we'll try to tie it all up. And I'm hoping to have an assessment next week. Okay? We'll see if we can do. I'm hoping. Okay? I'm hoping. So it's gonna be a quick topic. All right? It's very quick. So hopefully we can get to a place then on Friday where we can maybe finish up a couple of little things on Tuesday, review, then test on Thursday. Okay? Nice job, everybody.